Hi guys, so here we have valence electrons and oxidation numbers, so you can use your notes as well as the periodic tables. We'll talk about what valence electrons are as well as oxidation numbers. So valence electrons are energies in the outermost energy level of an atom. If we look here, and we've seen this one before when we talked about atomic radius, we can see that the outermost energy level will have a certain number of electrons in each group. So these are just the main group elements, groups 1A, 2A, 3A, 4A, and so on and so forth. So if we take a look at group 1A, hydrogen has one valence electron, meaning one electron in its outer shell. Same thing with lithium, sodium, and potassium. So anything in group 1 has only one valence electron, meaning only one electron in its outer energy level. Taking a look at group 2, let's see, we have beryllium here, which has two valence electrons. Magnesium also has two valence electrons, and calcium has those two valence electrons as well. So again, as you go down group 2A, there's two valence electrons. Group 3A, of course, there's three valence electrons in each of the atoms going down the group. There and there. Group 4A, four valence electrons. 5A has five valence electrons. 6A, six valence electrons. 7A is seven valence electrons. And of course, group 8A is eight valence electrons, except for helium. So we have to make a note here. Hydrogen and helium are a little funny. You know, hydrogen's going to be a nonmetal, yet it's hanging out over with the metals. Helium's over here, it has two valence electrons, yet it's not in group 2A. Well, the thing is that this first energy level, so the energy level right outside the nucleus, can only hold two valence electrons, two electrons in general. And so that's why helium isn't going to be over in group 2A, because that first energy level can't hold 8. It can only hold 2, which is the max number. So if we look here, neon has 8 valence electrons. That's the maximum number of electrons in that second energy level. In argon, here we have 8 as well, and same thing with krypton. We have 8 valence electrons. So here are the terms in valence electrons. Again, group 1A is 1 valence electron, group 2 is 2 valence electrons, group 13 or 3A, whichever way you want to number it, is 3, 14 or 4A or 4, group 15 or 5A has 5 valence electrons, 16 or 6A is 6, 17 or 7A is 7, and 18 or 8A is 8 valence electrons. So let's talk about oxidation numbers. So this is when atoms will gain or lose electrons to fulfill that outer energy level. So we said before that the helium can only hold two electrons in that first energy level, but anything below that can hold 8. So really what atoms do, or they combine with one another in order to fulfill that outer energy level to get those 8 valence electrons, or if you're in the case of helium, the 2 valence electrons. So when they either gain or lose electrons, or they can gain or lose electrons, and we call them the oxidation numbers. So when atoms lose electrons, they become positive. We call those cations. When atoms gain electrons, they become more negative. And the reason is for that electrons are negative, right? So if you gain more negative charges, they should become more negative. If you lose negative charges, they become more positive. So one thing to make sure you keep in mind, if you lose electrons, they become positive. They're called cations. And a way to help you remember cations is positive is if you look at that T, that can make a little plus sign for you, right? And then the other thing for anions is that when they gain electrons, they become negative, and they're called anions. So let's take a look here at calcium. We have 20 protons in the nucleus, and we know we have 20 protons because the atomic number is 20, and we'll talk about that a little later on as well. Down here, the lower left-hand side of every one of these boxes on the periodic table are the electron configuration, meaning you have pretty much what electrons are in each energy level. So the first has 2, the second has 8, the third has 8, and the fourth energy level here has 2 valence electrons. Now remember, atoms want to be able to gain or lose electrons in order to have a full energy level, outer energy level, meaning having 8 electrons. So in this case, calcium could gain 6, but it's actually easier, or it takes less energy for it to actually remove these 2. So when they remove these 2 electrons, they become something called an ion. So we can show calcium ion now. And let's think about this. We had 20 protons, but now we only have 18 negative electrons. So overall, since we have 20 positive charges and 18 negative charges, overall this should be a positive 2 charge. So calcium is a plus 2 charge, and I show that as a superscript in the top right-hand corner. Something else that also helps you out is in the top right-hand corner of each of the boxes, they show you what the oxidation numbers can be as well. So let's kind of show you, let's see, sodium. It'll be easier. So we have an electron configuration of 2, 8, and 8. So in order for this to have a full energy level or full outer shell, it'll actually lose that 1 electron. So since it's lost 1 electron, it's now going to be a plus 1 charge, hence why we have that plus 1 up there. So gaining and losing electrons, atoms, ions, we'll talk about all of those terms later on. But what I do want you to know is that there are some trends that are associated with this. So in group 1, and this is of course for the main group elements, once we get to the transition elements, they have more than one oxidation number or oxidation state, so they can be a little tricky. But group 1A has a plus 1 charge, 2 has a plus 2 charge, 3 is a plus 3, the 3A. 4A can be plus 4 or negative 4. 5A is negative 3, because if we show here, nitrogen has 5 valence electrons, so it actually only needs 1, 2, 3 more negative charges in order to essentially have a full outer shell. Anything in 6A is negative 2, 7A is negative 1, and 8A have no oxidation numbers because they already have a full outer energy level. So to summarize, valence electrons are the outer electrons. They're based on the group number. And oxidation number is when any of these atoms will gain or lose electrons to fulfill an outer shell. And we'll definitely go more in depth with that. That can be a little bit more confusing. So let me know if you guys have any questions, and I will talk to you guys later. See ya.